Recall the core requirements of collision theory. According to collision theory, for a chemical reaction to occur between reacting gas particles, they must satisfy three specific conditions. They must physically collide with one another. The colliding particles must possess a minimum threshold of kinetic energy, known as the activation energy, EA, to overcome electron-electron repulsions and initiate bond rearrangement. The particles must collide in a particular spatial orientation, geometric alignment, so that the specific atoms that are going to form new bonds actually come into contact. Analyze the parameters already accounted for in the problem. The scientist has already successfully calculated the rate of collisions between NO and number 3 that possess sufficient energy to overcome the activation energy. This means the first two criteria of collision theory, collision frequency and sufficient energy, have been fully integrated into their calculation. Identify the missing variable causing the discrepancy. Despite having enough energy, only a small fraction of these energetic collisions actually result in a reaction. This indicates that a third constraint is filtering out the majority of these otherwise successful collisions. Apply the orientation constraint, steric factor, because NO and number 3 are asymmetric, multi-atom molecules. They must collide with a highly specific alignment, e.g., the nitrogen atom of NO colliding directly with a specific oxygen atom of number 3 for the oxygen transfer to occur. If they collide sideways, backwards, or at an unfavorable angle, they will simply bounce off one another elastically without reacting, regardless of how much kinetic energy they carry. Conclude the correct option. The requirement for a particular collision orientation is the only factor that explains why the observed rate is only a small fraction of the calculated energetic collision rate, confirming option B as the correct answer. The correct answer is option B. The two reactant particles must collide with a particular orientation in order to react.